Hello and welcome back, all of you. Thank you for crediting this course, Business Intelligence and Analytics, going through the lectures and reading extra on the way. And I want to believe that the course has been learning full and you learned a different perspective of using data from the business problem perspective. When you want to address problems of business, you got a perspective that data that exist within your organization or enterprise can be used to solve your problems, okay, to gain insights about the problem and generate good solutions to solve the problems, okay. So that is the substance of the course, Business Intelligence and Analytics, to provide intelligence to managers or add to their intelligence when they take decisions, okay. And you can use it, do it descriptively, you can do it using advanced algorithms to predict, etc. So we have seen different methods for that already, okay. So in this session I am going to focus on certain new developments that is happening in technology, okay. So if you see technology as an environment, so you can see that there are certain new technologies, in particular artificial intelligence and blockchains, which are playing a very important role in organizations, the way job is carried out, the way decisions are made, and the way strategies are formulated. So therefore, we cannot ignore these technologies. In particular, if you are pursuing a domain of finance and accounting, it's very important to know what is the role of blockchains, okay. And particularly we learned about the ledger, okay. You know, the ledger is the heart of the matter in terms of the data and information it captures about transactions, and it is very important to keep the ledger intact, okay, and they should be immutable, okay. That is one aspect. And when it comes to AI, okay, the machine intelligence is actually multiplying, and in certain cases it is becoming smarter than human intelligence, okay. And that is a promise, that could also be a peril, okay, if a machine becomes super intelligent, okay, and it can work against humanity. So there are also fears in the technology circles as to what is going to happen. Of course, with the development of every new technology, there are actually promises and perils, and of course humanity in the form of governments and countries come together and find ways to address this. You know there is a potential of a hydrogen bomb. You can make it and destroy the whole world, okay, but we don't do that, okay. In a similar way, some of the fears about AI is misplaced, okay. So let's have a view as part of this course, what is AI, what is blockchain, and what roles they are playing in industry, what you should be aware, and what is the way forward, okay. So that's what we are going to see in this particular session. This is very incidental. A couple of days back, two scholars, John Hopefield and Geoffrey Hinton, received Nobel Prize in physics. And for what? Their contribution to foundational discoveries and inventions that enable machine learning with artificial neural networks. Okay. So this gentleman worked for several decades in neural networks, and in one sense understanding how human neural networks function and model that mathematically, and also discover methods by which the neural networks so created can learn from data, the way humans learn from data, okay. And that is the most important development that has happened in the recent times, okay. The neural networks as the engine of a AI system, okay, a neural network that learns from data and is able to predict or able to say what is going to happen next, what you're going to say next based on what you said in the past. Okay, so that is a very important development of our times. So, so if you look at the past of the artificial intelligence, okay, there is of course a history of several decades standing from the 40s, I would think, when Michelot and Pitts. Okay, Michelot was a neurologist and Pitts was a mathematician. They met in Chicago and lived together in the same home for 5 years, and at the end of 5 years there was some sort of technology transfer between the two, or I would say a excellent collaboration between the two, which produced a really impactful outcome, which is the model of a artificial neuron. Okay. There is the biological neuron and there is also the artificial neuron. I think in 1942 they published a paper in the Mathematical Bulletin of Biophysics, I think. So you see three disciplines. Okay, so this interdisciplinary interaction, okay, and building communities of that kind actually leads to revolutionary discoveries. Okay, and AI is one such discovery where biology meets maths and computer science. Okay, so you see the applications, and also you see how they have outsmarted humans in terms of their performance. Okay, so this is a visual representation of that available online. You can refer to that. There are a lot more graphs out there, but you can see that in certain areas like image recognition, language understanding, handwriting recognition, etc., the AI's accuracy has proven to be better than that of human accuracy. Okay, so so they are widely being adopted and used thanks to their established evidence of performance, be it in photo tagging, voice assistants, recommendation systems, self-driving cars, in healthcare. A lot of domains are actually increasingly using AI, and you can also see how the AI-based enterprises or startups are also growing. Okay, so the investments that is flowing into it, the new startups that are coming up, also tells us that this area is going to impact business and different functions of business, including accounting, finance, and HR, and so on and so forth. So we should be aware that technology is growing, and how am I going to be affected, and what should I know? Okay, so this has been, as I said in the beginning, historically true, that whenever there was a new technology, there was a fear of loss of jobs. Okay, and what is going to be the future of jobs, etc. Okay, and this is from The Economist, and you can actually look at which jobs are more likely to go and which jobs are going to stay, etc. Okay. Okay, so a discipline that is growing in its impact and is impacting AI substantially is the cognitive neuroscience, where scientists try to develop understanding about the functioning of the biological neuron, and that is the structure. There is a structure of multi-layer networks of neurons which function in the human brain, about 100 billion neurons. Okay, single neurons do exist, but they don't exist in an isolated way. They are connected to each other. Okay, and those connection strengths actually determine our intelligence and memory. Okay, so that particular functioning of the neural networks in terms of how they connect and what is the strength of connection, okay, determines the learning of a biological neural network. And it is that knowledge that actually is getting translated in the form of neural network training algorithms and being applied in artificial neural networks. Okay, so since we are first talking about neural networks as an engine of the artificial intelligence. The neuron is biological, and it is represented here in the slide that the neuron's terminal, it has two terminals, one at the beginning, other at the end or at the terminals. Okay, so the sensory neurons, okay, has so-called dendrites or projections here, and then there is a stem that finally reaches the terminal of the neuron. Okay, and the stem is called the axon, and so on. And you can see that two neurons communicate when the axon terminals of a neuron comes in contact with the dendrites, which is the receiver side. Okay, this is receiver, this is transmitter. Okay, the receiver and transmitter come close. Okay, and there the connection between two neurons is through a neurotransmitter, which is a chemical medium. Okay, and if the connection happens, okay, then that is called synapse. Okay, and that connection will have a strength of connection. It is not just connection, but there is also a strength or a weight that defines the connection. Okay. So at a time, as you saw in the previous slide, a neuron can be connected to 15,000 other neurons. Okay, so it's not just one neuron that can connect to a neuron, but multiple neurons can connect to the same neuron. Okay, so therefore it forms a network. Even at one node or one neuron receiver, there will be thousands of other neurons connected to it. Okay, or in other words, they are connected and communicating. Now, as I said in the beginning, the effort to understand how the brain works in terms of the neurons and their networks began in the 40s, and of course scientists started working in that direction, and by 50s there was a more refined representation of a neuron as an artificial neuron in a figurative mathematical form, okay, which is shown in this diagram. Okay, the neuron, the mathematical, semi-mathematical representation of a neuron, where a neuron has two compartments. First compartment is summative, other has a transfer function. Okay. Okay, you can see that these are all inputs. Okay, these inputs can be other neurons. Okay, the terminal nodes of other neurons. Okay, I1, I2, I3. There could be IN, and there is also a fixed bias. Okay, which a neuron has. Okay, they connect. When they connect with a given neuron, as I said, there is a connection strength which is decided by the weight of that connection or the strength of that connection. Okay, so W1, W2, W3 to Wn is the weight vector. Okay, I1 to In is the input vector. Okay, and what happens at the summing compartment is that it generates the weighted sum of the inputs, or in other words, this will output W1 into I1 plus W2 into I2 plus Wn into In plus the bias, whatever. Okay, but this is not the direct output of a neuron. The neuron actually produces the output based on a transfer function, okay, which is in the next department. So this output from the first compartment goes to the second compartment to the transfer function, and if the value of this output, okay, but based on the value of this output, the transfer function will decide the final output. Okay, so if the transfer function is a step function, the output can be either 0 or 1. If the total value, the weighted sum of this junction say is more than 0, then the output will be 1. If it is less than or equal to 0, the output will be 0. Okay. So that is what the transfer function will do if it is a step function. Here it is a logit, okay. It is a sigmoid function or a logit, and therefore it's an S curve. Okay. So therefore it will transfer the input here to the output based on the function that is given here, or value of the x, okay, which the first compartment produces would be the basis for the y or the output. Okay. So this is the representation of a artificial neuron, okay, a sum, weighted sum and a transfer function together produces an output from a neuron, and a neuron receives several inputs, okay, and all those inputs are multiplied by corresponding weights, okay, and that passes through a transfer function. This is the representation of a single neuron. Okay. Now this single neuron this output can connect to another neuron in the next layer. Okay. This becomes the input to another neuron, and it will function in the same way, and there may be output from other neurons coming here, okay, not just this, okay, and then it will have a transfer function, and that will be the next output. Okay. So this is O1, this is O2, and you can imagine neurons not as standing alone, but neurons are connected to each other. Okay. It is those connections that defines human intelligence. Okay. Now, how that happens, how that defines human intelligence requires more investigation or more studies. Those who read cognitive psychology will get a picture of the neural connectionist explanation of the human brain. So you can do further reading about it. My scope of mentioning this here is to understand how neural network or artificial neural network, okay, are developed and also trained. Okay, this is about training. So we just saw how neurons connect together and form a multi-layered network. Layered means each of this is a layer. Okay, this is a layer, this is a layer, input layer, hidden layer, okay, output layer, this is input layer. Like that, a neural network will have multiple layers, and each neuron is connected to every other neuron in the previous layer. You can see that. So this actually form a structure. There is a structure of a neural network. Okay, you can design a neural network. Okay, you can design a neural network. If you have 3 inputs and 1 output, you will have 3 neurons in the input layer, 1 neuron in the output layer, and you can say I have some hidden layers. Okay, that's a very early understanding of how neural networks can be designed. Okay, so a basic understanding. Okay, so let's assume you created some neural network. So the next important step in applying neural network is, well, it is not created to see it. It's like seeing a head, but it doesn't do anything. Okay, the neural network is supposed to learn and do certain actions. Okay, for example, if you are touching a hot surface, the brain should inform the muscles in some way, don't touch or withdraw your hand. Okay, the signal has to come from brain. Okay, how does that happen? Or in other words, the neural networks should learn from data and then produce the output. So how can neural network be trained? Okay, so there are also, this is algorithmic. Okay, there are training algorithms. Okay, so neural network structure, mathematical models were developed, as I said, long back, but the training algorithms took a longer time to become efficient, to become practical. Okay, so one of the early inventions was that of a gradient descent backpropagation algorithm. I just showed you Geoffrey Hinton actually contributed to developing gradient descent algorithms, basically to train the neural networks. Okay, and that actually, of course, it has got much more advanced today with large language models, but essentially this laid foundations for the growth of neural network as a area or as a intelligent algorithm to learn from data. Okay, so you can see that you are here inputting data. Okay, inputting data. You have a data set, say for the weather data for say 25 years in Chennai. So what you're going to do is, this is time series, right? So you're going to input that data, and this is supervised learning, what is depicted here. Okay, so when you input say T1 data, okay, T1's data as input, you are setting a target of when T1 was the input, T2, you know, if yesterday's temperature was T1, it is supposed to tell me what is today's temperature. So I should train it by saying when temperature was T1, T2 was this, okay, and it is supposed to actually produce T2 here. The predicted output should be T2, but it will not be T2, there will be an error. Okay, so that is the, let us take it as T2 cap. So the difference between T2 cap and T2, sorry, there is no cap here, okay, or hat as some people call it, T2 hat minus T2 is the error. You can see the error is back propagated, okay, in fact a function of the squared error, and that is used as a the squared error as a function of the weight. Okay, so E as a function of weight, okay, is actually used to derive the revised weights, okay, or to adjust a W. Okay, there are weights here for each connection, but the weight vector is adjusted based on the error. Okay, or in other words, the delta W is calculated based on the error that the network produces. Okay, and that is the method. The differential vector for the weights is computed with every training data set, and that way the neural networks is continually trained using multiple epochs or multiple iterations of the given data set till the error actually comes down and down and down. Okay, so then you know when the error, the prediction error actually goes down, you know that the network has learned how to predict the next day's temperature. Okay, so this is a very fundamental idea of neural network, suggesting that neural network emulates human brain structure of neurons. You create a structure and then you also have an algorithm to train that neural network. Training here meaning adjusting the connection strength between different neurons, which is called weights. Okay, so the weights are adjusted based on the error, differentially adjusted based on the error. Okay, that's a fundamental idea that drives neural network. Okay, and practically neural networks have been found to function very efficiently, or their performance for several applications is better than the traditional models. Okay, so this, of course, this test of performance of machine learning algorithms we have seen in certain cases. So you can actually train a neural network for a classification purpose. You can also train, you can actually also build a decision tree for the same classification application. You can test which one performs better. Okay, and usually for noisy and nonlinear data, okay, neural networks are found to function better or more accurately than other models. Okay, but this could be tested based on the application. So what I explained to you is neural networks at a very fundamental level, but the neural network I demonstrated to you in the diagram, which is actually moving only forward and there is no feedback from the output to the input. Okay, such networks are called feed forward backpropagation neural networks. This is what we have already seen. Okay, then there have been more improvements in neural networks in terms of their performance and the ability to train those neural networks for different applications like image recognition. The convolutional neural networks evolved. Okay, and then came the recurrent neural network, which has actually feedback. Unlike feed forward networks, RNN has feedback within the network. Okay, and the latest, of course, is the deep learning neural networks with transformer architecture, which is used in generative AI applications called large language models. Okay, they have been developed actually in the context of NLP to understand language, human language. Okay, and also to develop a conversational form of interaction with this sort of networks or algorithms, where you can give a prompt and from the system will respond to your prompt, and then you can ask a related question. It becomes a conversation. It's not like one time. Okay, so it learns the intention of the user and tries to provide an answer contextually, and that is what Gen AI is actually trained for or built for. And you can learn more about this through NPTEL and other resources. I have given some references here which perhaps would be useful to those who aspire to develop more competence in neural network based machine learning and also in AI as a whole. Yeah, so as I said, the machine learning algorithms which we described are actually either based on algorithms or based on statistics. But when we come to the ChatGPT sort of models, they have been designed actually to learn languages. Okay, so the NLP community interest drove the development of these models, but they used neural networks. Okay, they developed a architecture known as the transformer architecture, and then also worked on semantics. Okay, meaning. Okay, how to actually understand meaning of language, not just correlation of words and popular words, etc., which is called the bag of words analysis, but going beyond that, how can meaning be understood from sentences or expressions, and how can a language model converse back, okay, with a human agent. Okay, so that is the idea in large language models. Okay, so some of the path-breaking developments happened are given here. For example, word to vector, okay, is a also known as word embeddings. Okay, I will show you what is word embedding in the next slide, but essentially what is the meaning of a word, or what is a word associated with, okay, in terms of its similarity with other words. So in other words, you are trying to interpret or attribute meaning to a word in terms of its association with other words. Okay, such a vector is the word to vec or word embedding. Okay, so this was the beginning to develop semantics. Okay, and then an architecture called transformer architecture was developed for neural network, and that was published in 2022. Attention is all you need. This paper is available in public domain, and these two developments actually, of course there are a lot more to it, but I am just citing one or two here to show the direction towards which the Gen AI models got developed in the among the machine learning community, which were developed as language models, but they are used not only for language but also for images, for videos, audio, And several applications are actually today using language models, okay, using the transformer architecture. So word embedding is, as I said, okay, so you use a training data set, say from Wikipedia or social media, and then generate, say, words and their associations. For example, the word woman, okay. If you actually use Wikipedia data to train a large language model like built using neural networks, you can see that the word nurse, women will be associated with nurse, secretary, teacher, saleswoman, actress. Men will be associated with officer, hunter, commander, guard, and so on and so forth. Okay, and so it's not very different even if you use the social media data. Okay, one way it provides meaning, but on the other side you can also see the so-called prejudice, okay, or bias. Okay, we also should understand here that language models are based on certain training data. Okay, so just like you say, if a child is coming from a particular area or a particular community, how the child is going to behave is predictable to you. How the person's background is useful in understanding how the person is going to respond to situations. In a similar way, the Gen AI's response to your prompt or what you ask the Gen AI would depend on what data has been used to train it. Okay, so women are tagged as nurses and men are not tagged as nurses. Okay, they are officers. Why? You can see inherent bias in the data set itself. This is known as AI bias. Okay, and there are several news items you can see where recruitment was affected by this kind of biases in the AI algorithms. Okay, there is a movie Coded Bias. I encourage you to watch the movie. You will get a sense of the implications of using AI which has been trained using certain training data when you apply this to your organization. Okay, and if you are not aware of the biases, okay, you may actually harm individuals, okay, or it can be against the interest of employees and your organization. So therefore one has to be cautious. Okay, so that's the downside of the AI when you deploy it. Okay, and you can see, say, explain to you what is large language model, its applications. Although it is developed by an NLP community, its applications are growing in of course, language-based applications have galloped, and it is also finding applications in other areas like multimodal applications, vision, image generation, video, speech, and so on and so forth. Okay, so in multiple domains, you will see the application of the large language models like the ChatGPT. Okay, which is developed by OpenAI, and you know that all technology companies are developing their own LLMs like the Gemini. If you today search Google, okay, Google not only gives a list of results in an order, but it also at the tops gives you a summary. Okay, that summary is done by an AI agent, Google's AI agent, the Gemini. Okay, and so an advantage is that you get a summary, okay, which you are looking for, but you should also be careful using what data that summary is given. Okay, or the whole world is not using internet. The whole world or all communities are not using social media. Okay, all people are not actually reading Wikipedia. Okay, so the elite bias, in my words, okay, can influence the recommendations or the responses given by AI tools. So therefore, there is a need to adopt responsible AI practices, or there is need for regulation and policy. So worldwide this debate is going on, and that is the next compliance perhaps as accounting professionals you should be aware of. Are your AI systems complying with the regulation of the country you work. Okay, so for example, just like GDPR, there is an EU policy. Okay, EU AI policy is evolving. Okay, and EU countries will have to comply with it, and potentially countries doing business with EU nations will have to comply with EU's guidelines on AI. Okay, so that is a future. So in that context, compliance to AI would be a future challenge. Okay, when you work in your organization, work with foreign counterparts. So here is another case which I have mentioned about AI, which oftentimes is a black box. It's not oftentimes, AI is a black box model. Okay, you say ANN, which is a trained model. You give certain prompt or input, okay, it gives certain output. Okay, but we do not know what is the F that produce, the function that produce the output. Okay, this F is not known, it's a black box. Okay, it's a black box, meaning the function is not known. What is the mechanism by which the input gets converted to an output? If it is a regression function, you know there is a beta 1 x1 plus beta 2 x2 plus a bias and an error. This is known, or an intercept and an error is known. Okay, so you can sort of understand the mapping of input to the output using a function, a mathematical model. But in the case of ANN, there is no such conceivable mathematical model which can actually tell you this is the way input gets translated to output. Okay, therefore these are called black box models, and therefore when the algorithm produces certain output, how can I explain this to someone? For example, in the case, there are several cases that is reported in the coded bias. Okay, when a teacher was fired in a school in Texas based on the recommendation given by an AI algorithm, and apparently the teacher was a really good teacher, potentially because the teacher belonged to a particular community or a race. Okay, there was an action against that particular teacher. Now, the teacher asked, why am I fired? The answer is, our algorithm said you should be fired. That's not an answer. Okay, the school needs to explain. Okay, and black box models cannot explain because they don't have a formula that maps the input to the output. Okay, and that is an important problem that is known as explainability, interpretability and explainability. Okay, is a major challenge in the case of AI algorithms, which needs to be addressed. Okay, here is another case in point drawn from a research paper which is mentioned here. That is, a particular AI system actually predicted that if a patient is diagnosed with pneumonia and has a prior background of asthma, then the patient has lower risk. This is counterintuitive, and doctors will not accept it. Okay, doctors' training will show that a pneumonia patient with an asthma background has high risk, but here is AI which suggests that it has lower risk. Why? Okay, this needs explanation. Okay, and if you read the paper, well, AI actually got trained from data. Okay, and AI training data actually showed this, but it doesn't explain it. But when they actually try to seek reasons for this particular prediction, it was found that pneumonia patients with asthma background are given critical attention. Okay, they get more attention, and therefore usually they are admitted and treated with critical care. Okay, and therefore because the critical care they receive, their recovery is higher. Okay, and therefore our AI predicted that they have low risk. You see, low risk is different from higher attention in treatment. A higher attention in treatment they receive is interpreted or is predicted as lower risk, okay, and therefore there is something wrong here, okay. There is some mechanism which the model doesn't depict, without which the prediction actually becomes problematic, okay, difficult to interpret. This is another potential problem in the use of AI, okay. So therefore research community has developed these aspects which are important along with ML AI models, which is understandability, ability to make a human understand its function, comprehensibility, the model's ability to represent learned knowledge in a human understandable fashion, okay, using a diagram, using a mathematical formula, okay, but it should be representable, okay, and then ability to explain its meaning to a human, not only representation but also interpretability, okay. Explainability is more critical when it produces a particular output or prediction. Why so? Okay, it has to be explained. If you fire an employee, the employee should be told the reason why the employee is fired, okay, and why you have low risk in a particular condition should be explainable, okay, otherwise it is not acceptable, okay. And the sources of AI bias could be due to the training data, inaccurate data, limited features or variables, sample size disparities, and instead of using direct measures, you have used indirect measures or indicators, and so on and so forth. So there are several possibilities, okay, and skewed data is the most important one, as it is shown in the sense your sample comes from a Wikipedia or social media or Twitter or Reddit and so on. These are actually represented by people who use the internet and social media, okay, and it may not be representative of the communities where humans endeavor. Okay, and today models are competing for number of hidden layers and number of parameters. GPT-4 has up to 1.7 trillion parameters, that is what I've been told. So very, very complex models, and they perform, maybe outperform existing models, okay, all true, but can we interpret what they produce? Are they free from bias? Okay, so these are critical questions. How transparent are they? Okay, so here is a diagram that is taken from a research paper, recent research paper, which depicts model interpretability in the x-axis and model accuracy in the y-axis. And you can see that there is a trade-off between model accuracy and model interpretability, okay. For example, a model like the decision tree, okay, has reasonable accuracy, right, but they are very interpretable, because once you complete a decision tree induction, okay, you can have a very clear representation of that model diagrammatically or figuratively. You can also write the rules, okay, using simple English, okay, using code, okay, and when you write down all the rules using the if-then mode, you can understand what is the model, okay. But if you have too many variables and too many rules, it becomes difficult to comprehend, but still they can be represented, okay. But when you actually try to improve on the model performance and go up till the deep learning, which we just saw, the large language models, okay, they are very high and super performing in terms of their accuracy, but their interpretability actually is very low, okay. So that is, you can see a trade-off between the model interpretability and model accuracy, and therefore regulation will try to strike a balance between model accuracy and model interpretability, and the machine learning AI community is working on making the models interpretable, okay, and representable, okay. There are efforts going on in that direction as well. Before I close, since I said I will also talk about blockchains, which is a related development in technology, particularly of interest to accounting professionals and finance professionals, because you see what is very important in the profession of accounting and finance is confidentiality. Financial data should be confidential in the sense it should be disclosed to people who have the right to access that data. Okay, so you have to ensure confidentiality. You also have to ensure non-repudiation, okay, in financial data. Why so? An important requirement in transactions, in financial transactions, is that if I made a transaction, I should not deny that I made that transaction. Even if I deny, the system should be able to show, well, you are not right, you are telling wrong, you are lying, okay, or you are trying to mislead, because we have evidence, okay. So non-repudiation is the ability of a system to ensure that a person who participated in a particular transaction do not refuse that transaction, okay. For example, if you issue a check to a vendor and you sign that check and give to the vendor, and the vendor presents that check in a bank and gets the money from your account, and later on you write to the bank saying that, well, I did not issue that check, it's not my signature. You can contest, okay, because all that the bank has is a sample of your signature which is stored in their system, and they compare it, okay. You know, if they manually compare it, there could be errors, okay, and you can always challenge that, okay. So there is a potential for repudiation in this case. A system, if it can actually make a transaction non-repudiable, okay, non-repudiation as a feature of the system, that will be great for financial transactions, okay. And third important aspect of a ledger or a record of financial transaction should be that it should be immutable, okay, or integrity of the transaction. Or in other words, once the transaction is made and closed, no one should be able to change that transaction and transaction data, okay. So closed transaction should be immutable, okay. So these are most desirable features of the ledger, okay. And in fact, blockchains is a technology that ensures these features, okay. How does it ensure confidentiality? Confidentiality through encryption, okay. Okay, and it is also you can actually read more about encryption and symmetric key encryption and asymmetric key encryption. Asymmetric key encryption is widely used where there is a public key and private key. You encrypt using a public key and it cannot be opened using the public key. It can be opened only using a secret key which is in the possession of the recipient, okay. So it ensures that the data cannot be accessed by a third party because it is encrypted. Even if you access it, it cannot be read because it is something blah blah blah, you know, it is not the original data. It actually gets transformed into something else which can be decrypted only by a secret key, okay. So that is the idea of encryption, which provides confidentiality. And non-repudiation, okay. Non-repudiation is that that once you sign, okay, once you sign something, okay, today you see e-signatures, okay, this is also based on a key, okay, using we call it private key, okay. Once you transact and you agree to transact and you want to transact, and you can transact only with your private key, okay. Along with your transaction, a private key gets associated, okay. And once the transaction is completed along with your private key, okay, you cannot repudiate. You cannot refuse that you made the transaction. You did not make the transaction because your private key is associated with it. Okay, your signature is associated with it. Okay, so that is how blockchains ensure non-repudiation. And the third and more interesting aspect is immutability. Once a transaction is complete, it becomes a block. Okay, you can see a block is a record, it's a ledger. Okay, and it actually records a particular transaction and then creates something called a hash key. Hashing is a mathematical function. It produces for the entire transaction record, okay, which is a set, it produces one hash key. Okay, it could be 128, it could be 256. There is a length to the hash key. Once the hash key is produced, if you make any change, if you can, and if you try to make any changes, even one bit of a change in the transaction in the ledger, the hash key will change. And the next hash key can be totally different from the original hash key. So once the hash key is produced, the transaction is completed and it is sealed forever, because the key once produced becomes the final seal. It seals the transaction. Okay, and so a blockchain, it's called a chain because it's a chain of transactions. Okay, so each block refers to the previous block's hash key. Okay, it's a linked list. Okay, technically it's a linked list, linked through the hash keys. Okay, and it actually performs confidential transactions, non-repudiable transactions, and immutable transactions, and therefore they are very valuable in creating ledgers. Okay, with this characteristics. And this is the core technology behind cryptocurrency, which many of you are very aware of it, and some of you may be wanting to invest in it, because the blockchain technology has enabled cryptocurrency in the sense you can have a digital asset, okay, and digital transactions, which is immutable and totally safe and secure, because this technology, blockchain technology, ensures it. Okay, and it can have a decentralized structure. It is not centralized. It's not happening in one server. It's not controlled by a central bank or the government. It can actually be through automation without any human meddlers. Okay, you don't need a regulator like the banks, the central banks which control each country. Okay, so therefore this is like an ideal, right? So no banks control it, no central banks control it, no governments control it. It is automatically safe and secure, and it can just sustain itself. Okay, so therefore it's like a utopia, it's like an ideal, but the technology has certain merits in terms of decentralization, in terms of absence of human meddlers, because the technology itself makes it robust. But there are consequences to it in terms of, you must be watching this, price volatility, and the technology requires high computing power, and obviously it consumes a lot of power, and it's not green, it's not environmental friendly unless you use green energy for it. Okay, and more importantly, it's used by criminals. Okay, so when you actually do cyber attacks, they actually ask cryptocurrencies, because governments don't have much control on it at the moment. Okay, so there are pros and cons to it, but you see the crypto adoption is growing, and governments are starting their own digital currencies or cryptocurrencies in order to contest in this democratization of currency or financial system brought by the blockchain technology. Okay, so that is just an introduction to the technology that is changing the landscape of finance and accounting along with analytics. Okay, I only intended an introduction, and you need to read more and learn more to equip yourself with the strengths of the technologies, and also while learning them you should also know what are the consequences and be aware of evolving new regulations in this space. Thank you very much.